The launch of NASA's Voyager probes was like the start of an amazing trip into outer space. It demonstrated that we can monitor not just Earth, but also everything in our solar system and beyond. Even after 46 years, these incredible spacecraft are still providing scientists with new and stunning information about space. Although their memory is 3 million times smaller than that of our smartphones, and they're 38,000 times slower than our fastest 5G internet connection, these remarkable probes continue to lead the way and explore in space. Recently, Voyager 1 made an astonishing discovery in interstellar space, challenging everything we thought we knew about the universe. It found something so unusual that scientists are left scratching their heads. But what exactly did it find? And how does it redefine our understanding of the cosmos? Let's find out. On a special day, September 5, 1977, from Cape Canaveral in Florida, something amazing happened. Voyager 1 began its journey into space, launched by a powerful rocket called Titan Centaur. Just 15 days later, on August 20, 1977, Voyager 2 joined the adventure into the universe. Their main mission was to examine the big gas planets in our solar system like Jupiter and Saturn and the moons around them. However, these space travelers went above and beyond, venturing deep into our cosmic neighborhood and breaking numerous records. These spacecraft have been on an astonishingly long trip, lasting longer than any other spacecraft ever. They have traveled farther from Earth than anything humans have made before, even reaching interstellar space, a part of our galaxy that no one had explored before, more than 12 billion miles away from us. Now, Voyager 1 and Voyager 2 continue to surprise scientists with their discoveries. The Voyager twin probes have accomplished remarkable feats. Over 40 years ago, they observed the moons of Jupiter and Saturn, revealing that these moons were not just boring and full of craters like our moon, but were actually buzzing with activity. Voyager 2 was the first to swing by Uranus in 1986 and zoomed past Neptune 3 years later, making it the only spacecraft to have done so. To ensure the spacecraft keep functioning, NASA has turned off some unnecessary parts and heaters to save power, aiming to keep them operational until at least 2030. For the scientists and engineers who've been part of this incredible adventure from the start, it's a mix of happy and sad feelings. Just when they thought the Voyager missions were almost done, a shocking discovery emerged from outer space. The data sent back by Voyager 1 and its twin spacecraft have become a treasure trove for scientists, sparking numerous discoveries and igniting public excitement about space. These spacecraft were built meticulously, like stable platforms to take clear pictures and gather data while zooming through space. Even before reaching the outer planets, their pictures were already amazing scientists. Voyager 1 started sending pictures of Jupiter while still far from the planet. People at NASA's Jet Propulsion Laboratory were thrilled when they saw the first images of Jupiter's swirling clouds and the famous Great Red Spot. The big moment came when the Voyagers found something extraordinary on Jupiter's moon, which turned out to be the most active volcanic body in our solar system. Voyager 1's tools detected strange signals from Io, and the images showed huge volcanic eruptions. The Voyagers took over 33,000 pictures of Jupiter and its moons, showcasing the stunning landscapes. Another surprising discovery was that Jupiter has rings, although not very bright, making Jupiter even more interesting. Voyager 2 found that Europa, one of Jupiter's 53 moons, has a thick icy shell over 60 miles thick, leading scientists to wonder if such moons could harbor life. As the Voyagers left Jupiter, they used the planet's gravity to gain speed and continue their journey. Voyager 1 went close to Saturn's moon Titan, studying its complex chemistry before heading beyond our solar system. Voyager 2 had its own adventures, discovering 10 new moons of Uranus and observing the fast winds and ice volcanoes on Neptune. One key figure in keeping the Voyager missions going was the famous astronomer Carl Sagan, who insisted on taking a last set of pictures before turning off the cameras. This led to the iconic pale blue dot photo of Earth from 3.8 billion miles away. Despite using ancient 8-track tape systems, the Voyager probes continue to send valuable data. The tapes store critical science data about planets, moons, and space between stars, surviving extreme conditions like space radiation and temperature variations. This durability showcases the ingenuity of the mission planners. The Voyagers use gravity-assist maneuvers, a celestial dance with large planets, to gain the speed needed to visit multiple destinations. These maneuvers, like slingshots, allow them to save fuel and cover vast distances. The Deep Space Network, DSN, a global network of radio antennas, played a crucial role in maintaining communication with the Voyagers, capturing weak signals and sending commands. Interstellar space is slightly easier to reach than the far end of our solar system, but it still represents a significant frontier for exploration. The Voyager probes, launched by NASA in 1977, have been pioneers in reaching and studying this uncharted territory. After traveling through the vast expanse of our solar system, both Voyager 1 and Voyager 2 crossed a crucial boundary known as the heliopause. This is the point where the influence of the Sun's solar wind, a stream of charged particles emitted by the Sun, ends, and the interstellar matter, consisting of particles and magnetic fields from other stars, begins. The heliopause is not just a static boundary, it is a dynamic and turbulent region where the solar wind collides with the interstellar medium. This collision creates a complex environment filled with fluctuating magnetic fields and varying densities of particles. When the Voyagers crossed this boundary, they entered interstellar space, providing us with our first direct measurements from beyond the heliosphere, the protective bubble created by the Sun's solar wind. The findings from the Voyager probes in this turbulent region are invaluable. As they ventured beyond the heliopause, the data they collected began to challenge and refine our understanding of how the heliosphere interacts with interstellar space. The measurements of particle density, magnetic fields, and cosmic rays have given scientists critical insights into the nature of the interstellar medium and the forces at play at the edge of our solar system. These discoveries are helping scientists refine their models of the heliosphere's interaction with interstellar space, improving our understanding of the protective bubble around our solar system and its role in shielding us from cosmic radiation. The Voyager's journey into interstellar space represents a monumental achievement in space exploration, highlighting the incredible distances we can reach and the profound knowledge we can gain through persistent exploration and advanced technology. As the Voyager's power dwindles, we are preparing to say goodbye. These pioneering spacecraft, launched over 4 decades ago, are nearing the end of their mission capabilities as their power supplies diminish. Yet even as we brace for the inevitable cessation of their communications, the legacy of the Voyager probes endures, a testament to human ingenuity, perseverance, and curiosity. These remarkable machines have traveled farther than any human-made object, exploring the outer reaches of our solar system and venturing into interstellar space, sending back invaluable data and continuously inspiring us with their journey. Voyager 1 and Voyager 2 were launched in 1977, initially tasked with a grand tour of the outer planets. Their missions have far exceeded these initial goals. These spacecraft have provided humanity with its first close-up views of Jupiter, Saturn, Uranus, and Neptune, revolutionizing our understanding of these distant worlds and their moons. They have revealed active volcanoes on Io, geysers on Triton, and the thick icy crust of Europa, among many other discoveries. The photographs and data they have sent back have not only expanded our scientific knowledge, but also ignited the imaginations of millions of people around the globe. The Voyagers are now over 12 billion miles from Earth, traveling through interstellar space. Voyager 1 entered this realm in 2012, followed by Voyager 2 in 2018. Interstellar space is a region beyond the influence of the sun's solar wind, where the environment is dominated by particles and magnetic fields from other stars in the Milky Way galaxy. The data the Voyagers have sent back from this frontier has provided scientists with unprecedented insights into the nature of interstellar space and the interaction between the solar wind and the interstellar medium. Despite their incredible distance from Earth, the Voyagers continue to communicate with us through the Deep Space Network (DSN). This network of large radio antennas located in California, Spain, and Australia allows us to receive data from the probes and send them commands. The signals from the Voyagers are incredibly faint by the time they reach Earth, but the DSN's powerful antennas and sophisticated receivers can detect and interpret these signals, ensuring that we can still receive valuable information from these distant explorers. As the power available to the Voyagers decreases, NASA has been making adjustments to extend their operational lives as long as possible. This involves turning off non-essential systems and heaters to conserve energy. Despite these efforts, it is expected that the Voyagers will only be able to continue operating until around 2030. After that, they will no longer have enough power to send data back to Earth. When this time comes, we will be saying farewell to these incredible spacecraft, but their journey will continue. Voyager 1 is on a trajectory that will take it past Proxima Centauri, the closest star to the Sun, in about 16,700 years. Voyager 2, following a different path, will pass by the same star approximately 3,600 years later. These timelines are staggeringly long, far beyond any human time scale, illustrating the vastness of space and the endurance of the Voyager's mission. Long after our Sun has expended its fuel and ceased to shine, the Voyager spacecraft will continue their silent voyage through the cosmos, carrying with them a small piece of humanity. Each Voyager probe carries a golden record, a time capsule of sorts intended to communicate the story of our world to any extraterrestrial intelligence that might encounter them. These records contain sounds and images selected to portray the diversity of life and culture on Earth. They include greetings in 55 languages, a variety of music from different cultures and eras, natural sounds such as thunder and birdsong, and a printed message from President Jimmy Carter. The golden records are a message in a bottle, cast into the cosmic ocean, a symbol of humanity's hope and desire to reach out and connect with other intelligent beings in the universe. The Voyager journey has been one of the most ambitious and successful space missions ever undertaken. Their discoveries have challenged our understanding of the solar system and beyond, showing us the incredible diversity and complexity of the planets and moons in our own cosmic neighborhood. They have also provided a broader perspective on our place in the universe, highlighting the fragility and uniqueness of our home planet. As the Voyager's power dwindles and we prepare to say goodbye, it is worth reflecting on the significance of their mission. These spacecraft were designed and built in the 1970s using the technology of that era. Their longevity and success are a tribute to the skill and vision of the engineers and scientists who designed and built them. They have far exceeded their expected lifespans and have continued to send back valuable data long after their primary missions were completed. The legacy of the Voyager mission is not just in the scientific data they have collected but also in the inspiration they have provided. They have shown us that with determination, ingenuity, and a willingness to explore the unknown, we can achieve incredible things. The Voyagers have paved the way for future space exploration, demonstrating what is possible and inspiring new generations of scientists, engineers, and dreamers. Even as the Voyagers travel farther from Earth, their story remains a powerful reminder of the human spirit's quest for knowledge and understanding. Their journey is a testament to our desire to explore, to push the boundaries of what is known, and to seek out new frontiers. The data they have sent back will continue to be studied for years to come.